New coronavirus variants are making COVID-19 more transmissible. Why? Basically, inside the bodies of people who are infected, the coronavirus is mutating and evolving.
Viruses, you're making billions upon billions of new copies, and you're getting so many generations of the virus that it's much easier for viruses to evolve and adapt over time.
Now, this coronavirus mutates slowly compared to other kinds of viruses like the flu or HIV. On average, only 2 new mutations a month worldwide.
The virus basically jumps from one person to the other without changing because it's so quick. It infects cells very quickly, it makes copies very quickly. Even before the immune system has had a chance to put any pressure on the virus, it's already gone and infected somebody else.
This virus, fortunately, has a proofreading mechanism. However, it does accumulate mutation over time.
And in certain people who harbor the virus for long periods of time, weeks or months, you get more of these mutations stacking up.
Many of those individuals have immune deficiency problems. Their immune system doesn't work very well, and so they can't clear the virus, generating more and more mutations.
And though some of these people don't display symptoms, they shed lots of virus over the course of their lengthy infections.
Those isolated events are spilling out into the community and now leading to large numbers of new infections.
Take variant B117, first documented in the UK.
We were one of the groups that discovered it. There were 8 spike mutations.
Meaning mutations in the genes that make the protein that forms the coronavirus's distinctive spikes, which cover its outer surface and dock to the cells in our body.
These mutations allow it to bind more tightly to the ACE2 receptor that's on the human cell, which appears to allow it to replicate more efficiently as well.
All proteins, including the spike protein, are built from subunits called amino acids. Of the 8 changes in each piece of this variant's spike protein, 2 are deletions of a single amino acid, and 6 are amino acid substitutions. These different components change the shape of the spike protein slightly, which appear to make it easier for the coronavirus to invade a human cell. As a result, the UK variant is about 50% more transmissible than the original version, due, it seems, in large part to one of these substitutions.
In just a span of a few weeks, it's overtaken all the other circulating strains in the UK. It's a competition, right, between that new variant and the variant that's already present in the community.
The amount of virus in the nose appears to be higher in people with the new variant as compared to other strains. And that explains potentially why we're seeing higher transmission rates.
In other words, a person infected with this variant might be exhaling or expelling more virus, meaning anyone breathing the same air would be more likely to get infected.
That is a major concern because that means the virus can spread more quickly amongst the population.
Experts are concerned that the UK variant may spread quickly outside the UK, including in the US. There are other variants that have emerged as well, one in Brazil, another in South Africa. Both share one of the UK variant's spike mutations, and both appear more transmissible than the original version. Across these variants, additional mutations may help the coronavirus evade the antibodies developed by our immune systems in response to older versions of the virus, while other mutations might make the new strains even more infectious.
The fact that these strains are more transmissible also means that we need to do an even better job adhering to all of the public health interventions.
A new variant has also emerged in California. These aren't the first examples of a COVID-19 variant replacing an earlier version of the virus. Last spring, the D614G variant emerged and replicated more efficiently than the original Wuhan version.
This variant quickly spread worldwide and became the dominant strain.
So we've already seen it happen once with this virus.
But this time, we've got vaccines.
A SARS-CoV-2 strain that can escape from a vaccine would be a disaster.
The vaccines still appear to work against the UK variant. But the variants from South Africa and Brazil are more concerning. The vaccines may be less effective against them, since the vaccines trigger the production of antibodies custom-made to fight an earlier version of the virus.
If the vaccine doesn't elicit enough of an immune response, that those variants may not be as well covered by the vaccine.
The variants are probably going to lead to small increases in the number of vaccine failures, but the question is how big is that jump? And I think that's the thing we don't know yet.
The variants make the need for widespread vaccination even more urgent. Experts want fewer opportunities for these variants to find their way back to people with compromised immune systems, where they could mutate further, becoming super variants. The Pfizer-BioNTech and Moderna vaccines both rely on messenger RNA, a bit of genetic material that codes for the coronavirus spike protein. When it's injected into our bodies, our immune system learns to recognize a piece of the virus so that if the real thing ever infects us, we've already got the weaponry to fight it off. The current vaccines contain the RNA sequence of the original coronavirus spike protein. But one advantage of using RNA is you can just update the vaccine with the sequence of the new mutated spike protein. Both vaccine makers are working to do just this by developing an additional booster shot.
I do worry about having to do, sort of catch up with the vaccine.
One way to keep up with COVID and fight it off is to ramp up our surveillance by sequencing the virus. That is, reading out its genetic signature to identify mutations and new variants as they emerge.
Yes, if we do it right, we'll stay ahead of the virus, so we'll see these things popping up.
Right now, I would say that we're largely blind in this country. We're not doing a sufficient job of monitoring all of the viral variants and figuring out why the outbreak is so out of control in certain regions of the country.
Tracking these variants more closely will also help keep our testing up to date so we can actively detect the coronavirus strains in circulation. As more and more people are vaccinated, infections are expected to drop gradually. But we're racing against a fleet of increasingly transmissible coronavirus variants.
So we need to get a move on.
If we can get people vaccinated, I think that's the fastest way out of this nightmare.